Variance. This is also another measure that can be used to work out the spread of a data set. In an ungrouped data set, we can calculate the variance using this formula. So this is the mean of the squares minus the square of the mean. Now, this is the symbol we use for the variance. So let's take this example. Work out the variance for this data set. Here, the heights of 8 students in centimeters are measured. So this is an ungrouped data set. Now to calculate the variance, first let's add all the data values together. Then the total is 1425 centimeters. Now let's find the total of the squares of each of these data values. Square each of the height values, then the total is 254,307 centimeters squared. So as we saw earlier, the variance is the mean of the squares minus the square of the mean. Then the variance here is the mean of the squared heights minus the square of the mean heights. So using this formula, the variance equals 254,307 over 8 minus 1425 over 8 squared equals 59.9 centimeters squared. So here I gave the answer to 3 significant figures. Now here I divided by 8 as the height of 8 students are measured and hence there are 8 data values. The units of the final answer is centimeters squared because here as I squared all the heights, the units became centimeters squared, and when I squared the mean height values, the units became centimeters squared again. So the units of the final answer is centimeters squared. The units of the variance are the units of the data squared. Now, to find the variance in a grouped or ungrouped frequency table, we can use this formula. So here, f is the frequency for each group and this sigma f is the total frequency. So just like before, the variance is the mean of the squares minus the square of the mean. In my previous statistics video, I covered on how to calculate the mean in ungrouped data and grouped and ungrouped frequency table. So check them out first or else it might be confusing. Now let's take this example. In a science group, a record was kept of the number of days of absence each student had in a particular term. So the data here are presented in an ungrouped frequency table. Now first let's add all the frequencies together. So the total is 54. Now let's find the total of the products of each frequency times each data value. Then it's 12 times 0 plus 20 times 1 plus 10 times 2 plus 7 times 3 plus 5 times 4 equals 81. Now let's find the total of the products of each frequency times each data value squared. Then it's 12 times 0 squared plus 20 times 1 squared plus 10 times 2 squared plus 7 times 3 squared plus 5 times 4 squared equals 203. Now the variance is the mean of the squares minus the square of the mean. So using this formula, variance equals 203 over 54 minus 81 over 54 squared equals 1.51. Now, if the data are given in a group frequency table, you can calculate an estimate for the variance using the midpoint of each class interval. The variance of a group frequency table can still be calculated using this formula. Now, if we take this example, the data is presented here in a group frequency table. First, let's add all the frequencies together. So, the total is 80. Now, let's find the midpoints for each of these class intervals. So, the data here has gaps, and if we take the first class interval 20 to 29 minutes, the class boundaries for this class interval are 19.5 and 29.5. And hence, the midpoint is 24.5. I've already covered about the class boundaries and midpoints in one of my previous statistics videos, so if you want, check it out for more details. Now, the midpoints for the other class intervals are 34.5, 44.5, 54.5 and 64.5 respectively. Before estimating the variance, first let's calculate the total of the products of each frequency times the midpoint of each class interval. So it's 5 times 24.5 plus 10 times 34.5 plus 36 times 44.5 plus 20 times 54.5 plus 9 times 64.5 equals 3740 minutes. Now let's find the total of the products of each frequency times the square of the midpoints of each class interval. Then the total is 183,040. If we were to give units here, it's minutes squared, but that wouldn't make much sense, so I won't give units here. So using this formula, we can estimate the variance. Then it's 183,040 over 80 minus 3,740 over 80 squared equals 102. Standard deviation. The standard deviation is the square root of the variance. This was the symbol for variance, and since the standard deviation is the square root of the variance, this is the symbol for the standard deviation of a data set. So as we saw earlier, for an ungrouped dataset, we use this formula to calculate the variance, and since the standard deviation is the square root of the variance, We use this formula to calculate the standard deviation of an ungrouped dataset. So, in the previous example, we calculate the variance of this ungrouped dataset as 59.9 centimeters squared. Now, the standard deviation is the square root of 254,307 over 8 minus 1,425 over 8 squared equals 7.74 centimeters. Since the units of the variance are the units of the data squared, then the units of the standard deviation are the units of the data. So as we saw earlier, we use this formula to calculate the variance of a grouped and ungrouped frequency tables. And since the standard deviation is the square root of the variance, we use this formula to calculate the standard deviation for ungrouped and grouped frequency tables. Now, if we look back at this example, the data here are in an ungrouped frequency table and we found the variance as 1.51. So, the standard deviation for this data set is the square root of 203 over 54 minus 81 over 54 squared equals 1.23 days. And if the data are presented in a group frequency table, just like the variance, we can calculate an estimate for the standard deviation of the data using the midpoint of each class interval. So in this example, where the data are presented in a group frequency table, we calculate the variance as 102. Now, the standard deviation for this data set is the square root of 183,040 over 80 minus 3,740 over 80 squared equals 10.1 minutes.